Now we'll see what is a circular shift. Okay, let us see what is a circular shift. Now consider one sequence x of n, which is given as 4, 3, 2, 1. I have plotted them here at this position. Okay. So while calculating the DFT, we had seen in this DFT calculation we had taken, suppose I had xn as 3 samples, and to find 4-point DFT, 4-point DFT, to find 4-point DFT, we added we added 1 0. You know that periodic sequence was given as sample 1, that was 1 by 3, 1 by 3, 1 by 3. We added 1 0. So to make it n is equal to 4, this was what we had done in the DFT by default. But what is the reason behind this? This is coming from the technique called as periodic extension. Periodic extension. We've also seen that in the periodic property, x of n is equal to n plus n. Okay, now we will just check it out. What is the periodic extension? Now I will draw a sequence which is xpn. It's called as xpn. Now I have a sample 4, I have a sample 3, I have 2 and 1. What I will do is, I will add 2 more samples like this. I will add another cycle, 4, 3, then you can take it as 2 and 1. So this is my 0, this is 1, 2, 3, 4, 5, 6 and 7 and so on. Likewise, on the left hand side also I can build a 2, a 3, a 4. Okay. Again I can build this 2, 3 and a 4. So this is -1, -2, -3, -4, -5, -6, -7, -8. This is called as periodic extension. Now what has to be done with this periodic extension? Why are we interested in this? Now suppose I want to shift this by en minus 2. I want to shift by 2. What will happen? I'm going to make a linear shift. So I have already having the colors here. So 2 shifts means I will have my green color coming here. Third sample, that is there. 2 is here and a 1 is here. I will draw the further part, which is red in color, okay, which will be a 4, then a 3, then I 2. No, I will not go because it's coming out of pitch. Now here, these 4 samples have arrived at this position because of the shift. I have been dragging them to the right. 3 and 4. The two samples of the green have come here. 1, 2, 3 and 4. And similarly there will be a drag from this side. Now, if I want to take only these 4 samples, I want to take, what are these samples? 2, 3, 4. One cycle if I want to take only the 4 samples, which will create x dash n. Collecting them, I will get a x dash n. So I will keep these samples as it is. 2, this is 1. I will take this as 4. This will be 3. Now the values are 0, 1, 2 and 3. This is one cycle for me. Okay. Now this has been obtained. Now x dash n x dash n is nothing but the linear shift by a 2 factor. Okay, it's called as linear shift by 2 factor. So what do I mean by this? I will write down the sequences as here. I have written the sequence as xn is 4321. See, xn is 4321 that I have taken, and x dash n is coming as 2, 1, 4 and 3 that I have put here on this page. Okay, I have covered the first 4 samples. Now what are you trying to achieve with this? I'm trying to relate this shift linear shift to circular shift. Let us see whether there is such a relation. Okay, now what we have done is I have drawn 2 cycles, 2 circles. The first is going to give me x of n. The second is going to give me the x dash n, which is the linear shifted periodic sequence. Now you can go either clockwise or anti-clockwise. So we have collected this as counterclockwise. Now I will see that this is my first sample, x0. I will put it as 4. I will have it as 3. I will have it as 2. And it is going to be a 1. Now I will try to put my values of x dash n also into this. It will be 2, it will be 1, it will be 4 and 3. Okay. Now let us understand how the circular shift, how the circular shift of DT sequence is represented. X dash n is represented as x of n minus k modulo n. or you can also say x double bracket n minus k for the order n. This is the representation of circular shift. Now here k has been taken as 2 in our example. Okay. Now after having some literature on this, if k has been taken as 2, n is 4, n is 4. If I want to go with this, x dash n is equal to x circular shift of 4. Let us prove ourselves whether we'll get the same values. N equal to 0. So x dash of 0 is equal to circular n is 0 means minus 2 for this 4. This is going to be, now when I go for this minus values, I should insert a n here. So n is 4. 4 minus 2 is equal to x of 2, that is equal to 2. X of 2 is equal to 2. Is it x of 2 is equal to 2? X of 0, x of 1, x of 2? Yes, is equal to 2. Okay, so this is my x of 0. This has become x dash of 0. Right? That I have seen here. Now at n is equal to 1, x dash of 1 is equal to x modular, it is circular shift. N is equal to 1 minus 2 modular 4, you can say like this. Now because I get it as minus 1, I will add in the linear the 4 minus 1. This will be x of 3. This is coming as, x of 3 is coming as 1. So is this x dash of 1? Yes. X dash of 1 is 1. Just check. Okay. Now, when n is taken as 2, let us see what happens. X dash 2. I want to find the value of x dash 2 from the linear shift, is it not? So, I have the modulo of 2 minus 2. This is equal to a 0. Okay. So, if I take it as 4 minus 0 or 0, it is one and the same. So, it is x dash of 0, which is equal to x dash of 2, which is 4. I have this x equal to 4. Now I want to find for n is equal to 3. X dash of 3 is equal to x circular 3 minus 2, 4. That is nothing but 1. I did not go for the further part. This is a linear. X of 1, what is x of 1? 0 and 1, it's 2. 3. X of 1 is 3, which is equal to x dash of 3. So my x dash of 3 will be equal to, so this is how x dash n is a circular shift shifted by 2 units counterclockwise. Counterclockwise. This, since counterclockwise, is positive direction. It's a delayed DT sequence. DT sequence. That is why. If you take clockwise, it will be negative direction. Advanced DT signal. This way also we can go for. The circular property has a big importance, circular shift property, in our in the solutions of different properties. Okay, so in the next part we'll see the actual property of time domain shift.